Can we please welcome to the stage Tonmoy Ghosh to celebrate him as the 2025 VISTA winner from Embry-Riddle Aeronautical University.
Hi, I am Tonmoy Ghosh. I think you already have my introduction, so I'll just give a brief introduction. I am just a master's student in Embry-Riddle Aeronautical University in the civil engineering department. So today I'll be talking about the use of low-cost air quality sensors to address environmental justice. First, we'll go over the National Ambient Air Quality Standards, the NAAQS, defined by the US Environmental Protection Agency, the US EPA. So, under the NAAQS, US EPA monitors 6 criteria pollutant that is harmful to human health, and one of them is particulate matter. PM is the short form for that. So, during monitoring PM, US EPA actually monitors 2 different types. One is PM 2.5, another is PM 10. PM 2.5 stands for the fine particulate matter having aerodynamic diameter less than 2.5 microns, where the PM 10 stands for the particles having aerodynamic diameter that those have aerodynamic diameter less than 10 microns. So, the motivation behind our research initially was to improve the accessibility of low cost air quality sensors and also increase the number of air quality observations. And we also want to increase the spatial resolutions of low cost sensors using 3 different multidimensional modes of operations. They are respectively stationary and we have named them the mobile setup, we have named them as 2D and 3D. The 2D would be our sensor setup mounted on carts that would collect data while driving through the roadways. And under the 3D modes of operation, we will have the mobile on unmanned aerial vehicle, where we will also be able to observe the change in the concentration of particulate matters along with the change in altitudes. So, why it is significant to Florida? So, Florida is #1 in prescribed fires. Every year, the Forest Service will issue approximately 88,000 authorization to the landowners and the agencies to prescribe burn around 2.1 million acres of land. And Florida has already been facing issues regarding the climate change. There has been frequent hurricanes, and we also have a concern regarding the sea level rising. So now I will go over the conventional monitors. These are the conventional monitors used by US environmental protection agencies. These conventional monitors, they use 2 different types of protocols. One is FRM, that is a Federal Reference Method, and another is a FEM, that is a Federal Equivalent Method to measure the concentration of particulate matter. And they use the filter based and beta attenuation method measurement techniques for this measurement of concentration of particulate matters. So, these monitors they are very accurate, their data, and they are stationary, but the problem with them is they are very costly. They are labor intensive as well as they have a lower resolution of data spatiality because they are very few in numbers along with the as per the areas. Then comes our low cost air quality sensors. So, we have been using 4 different kind of sensors. The first one is AlphaSense OPCN3, which is basically optical particle counter. Then comes our purple air sensor and this green one here is the Sensirion air sensor, and on the bottom right there is our VoLo QT400 that we have been using. So, these low cost sensor, as per their name, they have a very lower price, and they have very lower maintenance cost as well. They are smaller in sizes, hence easily deployable, and they can be deployed on mobile vehicles as well. So, these sensors can play a vital role in ensuring the high resolution of data on a spatial scale through an organized network of deployment. So we are collecting, we have started the data collection. So on the right, we have our stationary setup. It's in our lab. In the middle, we have our mobile setup that I have been talking about. It would be, it is mounted on the car. So there is no car, it's kept on a table. So that's why the picture looks like this. And here we have the sensor setup mounted on our drone. So this three, we would like to correlate between all these three setups and the acquired data through all three processes. And it is a small representation of our work till now. So what we are doing, this one here, the sensor one on this vertical axis on this both figures, that is actually the PM concentration we acquired through the VoLo AQT 400 sensor. And the horizontal axis, there we have two different sensors. So like the sensor 2 and 3, they respectively refers to two different Sensirion sensors who were deployed at the same location at the same time. So from this data, we can see the R square value is 0.81 and 0.83 respectively for both the figures. From this we can say we have actually good quality of data, and we have used this method for evaluating all of our sensors. And finally comes the environmental justice part, so and our local sensors role in addressing it. So I have put some figures that is related to Orlando. The first A, B, and C. These three figures respectively refers to the air toxic cancers and air toxic respiratory hypopnea index. Another one is low life expectancy. So we can see this is a bit colorful. This red areas, they actually refers to the data that lies in the 95 to 100 percentile zone. Then comes the brown region, which are here. They lies in the 90 to 95% zone. And then comes the yellow area that lies in the 80% to 98 percentile zone, 90 percentile zone. So we can see just in Orlando, we have actually quite a bit of a risk factor regarding these issues. And on the right, we have the PM concentration from the diesel combustion, and for the figure A, we have a total PM 2.5 concentration in Orlando. So from this figure, I can say that we should be concerned about this particulate matter emissions, because we are continuously breathing, and we are actually breathing these particulate matters every second we are breathing. We need to address this problem, and we need to work on this as well. Thank you. If you have any questions, you can feel free to reach out to my mail. That's all. Thank you.
For your brilliance in your work. Are you bringing this for him? Okay, come on up. Stand in the middle.
Oh.
He's here to present you with an award.
First, I just wanted to comment why this project really stood out. A lot of the narrative is about how climate change is affecting us globally, but we're trying to add to that narrative, like showing the effects of the local effects of fossil fuels, so that we can get community support. And so we've done at least 4 grants in the past, trying to connect, showing like connection between health locally and pollution and effects of fossil fuels, from a grant with MIT. Then we did one with Environmental Defense Fund measuring pollution in cities. And then recently we have ongoing some big studies analyzing the health effects from the fires in California. And one we just kicked off, the southern states, linking air pollution to actual health effects and ongoing. So, but in order to collect these data points, you have to be able to measure things. You have to be able to measure the state of health accurately, and you have to be able to measure the pollution accurately, and that's basically what this helps accomplish, which is why I'm excited to present this award. This could be a significant part of the whole effort, and it was very innovative. And so with that, we'd like to present the VISTA Award.
Thank you.
I'm going to bring you a check.
Thank you. Thanks a lot.
We have to come over here.
Okay, can I go? Yeah, thank you.